Hey, what's going on, guys? Xiangqi here. In order to proceed with our Go playing program, I think it's a really good idea to connect it to the GUI because it's easier to input the moves and really easier to debug. And there is another reason for doing so. So let me explain. The original program by Jonathan K. Millen had a limitation of that the engine was only capable of playing black, like always playing first, having a handicap in that sort of way. But I actually want our program to be able to play for both sides. So and another problem that the logic of implemented rules itself, like for instance capturing the pieces in case if the group is closed, has been embedded into the AI itself, and that's not really a flexible way of doing things. But again, assuming the 1981 year and the Q1 target computer this program was written for, that's pretty clear, like why they consider that approach. But instead of deriving the program from the text-based interface, I actually want to consider this so-called Go text protocol and from now on start debugging within the GUI. And the GUI we're going to be using is called Sabaki GUI. I've been introducing that GUI previously, so let's open the Sabaki GUI here. It's a modern cross-platform GUI for playing Go, which is based on Electron.js. So it's truly cross-platform, web-based like interface, absolutely fantastic. And it's incredibly easy to work with in terms of this GTP protocol. So again, like we're gonna be sticking to the version 1 because the version 2 is more like for the engine supporting the neural networks and the specific commands. To like give the estimate like where the probability of winning and things like that. So a more sophisticated information being returned from the engine as an output. While the first version is just the bare like here, just to give you an idea. Here is the session. So like board size, setting the board size, clearing the board, like the command to synchronize the internal board state, the command to generate and the command for engine, tell engine to generate the move. That's pretty much all about it. So just engine generates the moves in like equal sign, and if the GUI we're using is not using this command number or ID, so it's not using this ID, so just using the equal signs and sign, and then just in the uppercase the coordinate in the algebraic notation, just like in chess. All right, so that's pretty much all about it. So in this video in particular, we'll make the GUI see the engine, so sort of an initialization, the basic things like the name, version, protocol version, and things like that. So there is a really nice information here in regards to how to work with the protocol, but a simpler approach and the more straightforward one is just trying to run the existing engine to see like how the initializing works, and then we can switch back to this commands. Well, okay, so now let's have a look at the log file generated by the Sabaki GUI, just in order to get a little bit more clear in regards to what's the starting sequence of the command that your engine needs to process in order to get initialized within the GUI. So within the Sabaki GUI, if we go to manage engines, and here we have this enable GTP login to directory, right? So whatever path you specify here, you will have the file where the log comes into. So here is the file. I've opened this in my code editor. So if I now try to ask the GUI to load the engine, so I'm using Apache here. So Apache just loaded, initialized, and if we have a look at the log file, here is what it comes here. All right. So the first 4 lines are the most essential in order to get the engine started. So we need to kickstart with implementing these commands. All right, so here is the source code from the previous part. So let's actually run the code. So Python 3 wally03.py. So here is the output from the previous part. So we've just counted the stones within the block and its liberties, so fairly enough. Now we don't really need this main anymore, so I want to get rid of this, and I don't want this. So here we want to provide the GTP communication protocol. So dev GTP, and here this is the main loop, main GTP loop. So simply while true. And by the way, in order to, so we'll need the version for our engine. So the version is equal to 0.1, for instance, and also I want to import the sys module to exit on quit command. Okay, so while true, so here we want to accept GUI command. So command is equal to just simply input in Python. This is fairly enough to do so. And now want to handle the commands. So if, and now let's have a look at the commands. So name version, protocol version. So if name in command, in this case, want to print. And here is the specification for the protocol. So we should start by printing the equal sign, which means the engine has accepted the command, then the space, then whatever response, and then at the end there should be 2 new lines. But since Python actually prints a new line at the end, if otherwise not specified like this, then it's fairly enough to have only 1 new line here. But again, if you don't have a new line automatically being added by the print statement, then make sure to make 2 new lines here. All right, hope it's clear. So the next command, so elif and version in command. In this case, I want to print equal sign, then space would get added automatically, then the version, and then the new line at the end. Okay, elif. The next thing to consider, protocol version. So this is very essential. So protocol version. So if protocol version in command, in this case, I want to print equals to 1, since we're going to be using the first version, which is easier to work with. That's the case. So elif list commands in here, just the protocol version. Copy, and so if list commands in command, in this case, want to print this, right? And also there is a quit command, so elif quit in command. In this case, want to say sys.exit, so we just exit from the process. Okay, and otherwise, so else, I want to say, I just want to print equal sign and the new line character. And what we do here, one just skip the unsupported, currently unsupported commands, or just unsupported commands. Yeah, so this is essential in order to avoid engine from to prevent an engine from crashing, basically. So yeah, okay, so let's start GTP communication. All right, and GTP, and let's test this out. So name, we got it. Version, we got it. List commands, protocol version, and the protocol version itself 1.0, which is absolutely fantastic. Okay, so now we're ready to add the engine to the GUI. This is fairly enough to get it initialized, basically. So I'm going back to Sabaki GUI here. Let's clear the console. Let's detach Patchy, manage engines, and click the add button. Now the name would be Wally. Now the path. Here I'm using Python 3 since I'm not using the binary executable here, but just the Python interpreter to run my engine. If you have the direct binary executable, you just provide the path in regards to your operating system to this. like your operating system path, absolute path to whatever binary executable you want to run under this GUI. In my case, I'm running this with Python, so Python is the first, and then the argument is which script to run using the Python interpreter here. So to figure that out, I need to get the path. So I'm getting the path here, and here, right? And wally03.py. This is the exact version that we're currently using here. I would be changing this to 4, 5, 6, etc. by the time we're gonna be following along with the new files. Well, when the new tutorials comes, that would be different file name. So we can easily change this here. Close. Let's make sure that the path has been stored. So Wally Python 3, and the path is here. So if I did everything properly, it now should initialize the engine, and it does indeed. So now let's have a look at the log. So the log has been updated, and now we see that Apache quits, engine stopped, and now we have a new engine comes onto the stage. So name, version, protocol. So these are the commands that GUI sends to the engine, and engine starts, and it just reports the name, the protocol version. Well, I'm not sure what exactly. Oh yeah, this is okay. Okay, so I'm not really sure. The version is 1.0, and the protocol should be equal to 1. So, well, since it works, it doesn't really matter that much. But okay, so the name here, version 1.0, protocol version is equal 1.0 as well. Well, this is a little bit strange. Just hold on a sec, guys. All right, yeah, here also gives a little bit wrong. So protocol version shouldn't be like that. So let's just stop here. Yeah, by the way, quiz, which is good. Detach. So where did I make that mistake? Okay, protocol version. So why prints 1.0? There's definitely something goes wrong here. Right, I probably just need to swap them like so. So again, name, version, protocol, version. Okay, and list commands. Great. So now here the protocol version equals 1, like this. Protocol version, yeah, so this should be fairly nice. Okay, let's try again. So clearing the console, starting Wally, yeah, now protocol version equals 1. Now this is okay. And yeah, list commands, protocol version. Okay, and now we want, for instance, Wally to be playing as white. It can't do so because it doesn't play yet, but I just want to give you an idea. So here we place the stone. And what happens next? So here is the commands the GUI sent into the engine. So it tries to set the commit. We don't care about this, so we just skip the command by saying =, in response. Then setting the board size. This is important. This is what we're gonna be handling in the future videos, in the next tutorials. Clearing the board. The board is also essential. And now here play for black, play E7. So we need to synchronize the internal board with whatever we have in the GUI. This is essential. And then since it's playing as the white, the engine is being asked to generate moves for white pieces. And since it just says equals and nothing else further on, it's treated to be as the pass move, and hence the sound in the GUI. So you see, like, pass, just this moves, like just pass. So now we can put a placeholder here for this gen move, just to give you an idea that whatever like some pre-coded, hard-coded move that engine does can actually be seen by the GUI. So let's try that. So clearing console here, detaching the engine, and here we can say elif, and now gen move in command. In this case, want to say, well, for now, I can just print it here really. Just print and equals sign, and for instance, let's say hardcode E2, for instance, and the new line character at the end. So let's try again. Now, just let's create a new game. Don't save. All right, and Wally. Okay, so wanted to play as white player, for instance. Okay, and you see like the engine has just responded with the pre-coded E2, and we see this in the GUI, which proved the concept that engine and GUI actually do work properly. And now, what I really love about the Sabaki GUI, that see like it allows you to play the illegal moves, and you might be wondering this is not good, but for debugging this is really nice because otherwise it would just be crashed. But now we can still test even though the engine is just a placeholder here. So whatever move I make, it's just still a response with the same move, and even if I capture this, it would be capturing. You see the sound? Here the sound, it just captures, like engine puts here and it captures, and so on. So, which proves the concept that actually once the GUI makes the move, engine receives that and it can do something in response. So from now on, we can actually start implementing all of these basic commands that are responsible for the interaction between the engine and the GUI. This is it from my side, guys. Hope you enjoyed this tutorial and learned something interesting out of it. Thanks for watching. See you next time. Take care.